Assalamualaikum and good day everyone. So we're going to continue the chapter 5 on flip-flop. So the next subtopic is active high, active low concept. I believe everyone already know based on the previous chapter, and we also will cover on all type of SC flip-flop. We have SC, we have JK, and we also have D flip-flop. Alright. Okay, so what is active high and active low concept? So like I already explained before, so active high means that when an input or output line has no bubble on it. Okay. Active low when an input or output line has bubble on it. Okay, you can see this one. Okay, from the previous subtopic, we have non-latch. We also have no latch. So we have non-latch with this active low input because we have bubble in the input. And this one is active high input. There's no bubble. So means that the input is active when it is high levels. And this one, it is active when the input is low. Alright, so what is synchronous and asynchronous system? In sequential circuit, we can classify as either clock synchronous or unclocked. We call it as asynchronous. Remember that when it is synchronous, it will involve with clock. Asynchronous means that we don't put clock there. Same like our class. Synchronous means it is like real-time class. Asynchronous like I'm uploading the video and you can watch it anytime that you want. So it won't affect any clock, anytime. So synchronous system is respond to a change of input signal only at discrete instant of time and determined by the clock input. The output respond instead with the control input of clock. So synchronous depends on the clock signal. Asynchronous system respond to a change of input signal at any instant of time as it is not regulated by a clock input. So output respond immediately to input changes. So anytime input change, the output will respond immediately to the input changes. Differ from the synchronous system, if the clock signal is not changed, even any input changes won't affect the output. Alright, so this is clock signal. So what is clock signal? Clock signal is periodic waveform consisting of equally spaced pulses. We have T as period. We have T here as the pulse there. Alright. And we have rising edge. This is rising edge. Sorry. Okay. Okay. We have rising edge. Sorry. So rising edge is at the top and we have falling edge here. So like this is we have clock. So rising edge is from 0 to 1. 0 to 1. Transition between 0 to 1 and 1 to 0 we call it as falling edge. The rising edge of clock is the positive going transition. We call it as PGT. And falling edge of the clock pulse is negative going transition, or we call it as NGT. So just remember NGT is from high to low. Like for example, you can imagine like you having a money and then you don't have money. So it will become negative. So no negative going transition. From no money you get money, so it is positive thing. So positive going transition. So it's like this. So positive going transition is over here. Negative going transition is here. So when clock change from 0 to 1 is positive going transition. When clock goes from 1 to 0 is negative going transition. So edges can also refer to as leading or trailing. So this is the type of flip-flop that will be covered in this video, in this chapter. So we have SC or SR flip-flop. We have D flip-flop. We also have JK flip-flop. Alright, and you can see here there's two different clock. We have positive going transition and we also have negative going transition. So the negative going transition, the difference is we have bubble in the negative going transition. So means that the clock with no bubble means it is triggered by positive going transition. Alright, first we move on to the edge trigger SC flip-flop or edge trigger SR flip-flop. It is the same name. C is reset, or we can also use clear. So difference between latch and flip-flop is the output changes only at either PGT or NGT of clock pulse. Like I said previously, when there's a clock signal trigger, then the output will affect based on the input changes from the S and C. So we also have S, we have also C as the input, and we also another additional input S, we call it S clock or clock pulses. Right? So this is the circuit inside the SR or SC flip-flop. So it using the NOR gate. And we have Q and Q bar output. So the logic symbol of SC flip-flop is like this. So you can see here, this active high input of for S and C. So it means it based on the NOR gate. So NOR gate, when 0, 0, it is whole. 1, 1 is invalid. When 0, 1, we activate the clear. So that's why we get clock QS clear. When we activate the set, we get output QS 1 or set. So this one is negative going transition and this one is positive going transition. So for example, you need to sketch the Q for the SC flip-flop. So the first thing that you need to do is draw the vertical line for the every edge. So this one is SC flip-flop triggered for NGT because it is labeling here. So draw the diagonal line at every triggering edge. Don't draw the diagonal line for every triggering edge, positive and negative. You need to see what is the question or what is the type of the SC flip-flop. If the SC flip-flop based on the PGT clock, so you need to draw the vertical line at the positive trail, the rising edge of clock. But this one, it is depends on the falling edge clock or NGT, negative going transition. So the second step is you need to evaluate the Q at every triggering edge. So for example, this one. So we need to evaluate the the Q at every triggering edge based on the input at before the edge. So before the edge, the value of S and C is 1 and 0. For example, the first one, the first clock. For example, the second clock here, the S and C is 0, 1. Alright? So you can expect this one is 1, 0. The output will become 1 over here. The output will become after the clock edge, not before, not under the SC input change. It will be effect after the clock over here. Right? So let's say here 1, 0, the output will become 1 over here. At second clock 0, 1, it will become 0 over here. The third clock 0, 0, it will remain unchanged, 0 from the previous. 1, 0 supposed to be 1 at the Q. The next clock here is 0, 0. It will remain unchanged from previous one. Q is 1. 0, 1 will become 0, and 1, 0 will become 1. So you can see the same here. Okay. So the next step is you need to draw the Q, just following the value Q that you evaluate in the previous step. So this is another example of negative NGT of SC flip-flop. So the output will trigger after the clock. Alright. So let's see here 1 0 1 0. So the output will be effect after the clock age. Compared to the QR no latch, no latch means that SR latch from the NOR gate will be different. The no latch Q will be effect every time the changes of S and C. So you can see the difference here. Means that the no latch respond immediately when the SC input is changed. So that's why we call SC flip-flop is age triggered, and for latch we call it as level sensitive trigger. So like this one, if the input signal S and C refer to figure are applied to PGT, so means that PGT is positive going transition. So over here, over here, over here, over here. So what will be the waveform of output Q? We need to assume Q is 0. So we have Q over here, initially is 0. So the first one is 1 0. So Q will become 1. And then the next clock is 0 1. So it will change 0. 0 0 is 0 until the next clock. 1 0 is 1. 1. And then 0 0 is remain unchanged until the next clock. 0 0 is 0. Okay. So the next flip-flop is JK flip-flop. The difference between JK flip-flop and SC flip-flop, the input is J and K, and we also have clock here. There's a different connection inside the JK logic circuit. Alright, so this advantage of SC flip-flop in the previous slide is we have the existence of invalid input when S equal to 1 and C equal to 1. We have invalid output. So to avoid this existence of invalid input, we use JK flip-flop, because in JK flip-flop, when the input is 1 1, the output will be toggle. So what is toggle? Toggle is if the previous input is previous output is 1, after toggle it will become 0. It will invert the previous state. So this is the logic symbol for JK flip-flop. We have positive PGT and we also have negative going transition. So the behavior is similar to the SC flip-flop except for the input when JK is 1 1. It will become toggle. So for example, this one, sorry, this one. Okay, let's say this is PGT JK flip-flop. So every clock of PGT, so like for example 0 0 here, it will hold. So this one will hold. So the second clock is 0 1, so it will be clear. The third clock is 1 0, it will set at the output. The fourth clock is 0 1, it will clear over here. And then the next clock is 1 1, it will toggle. So you can see toggle, the previous is 0, the next after clock is 1. And this one 1 1 also, so it will toggle from the previous is 1, it will become 0. Alright, so the next flip-flop is when we have asynchronous preset and we have clear input. Alright, so this one we call it as asynchronous input. Means that preset and clear input will affect the flip-flop instantaneously, although the clock pulse is not in transition. Means that when these input are active low, when the input is active, immediately the output will change depends on which asynchronous input is active. So let's say we want to active the preset bar. Preset bar, when it is active low or active, the Q will immediately become 1. When the clear bar is active, the Q will become 0 immediately, not depending on clock age. So the circuit is like this. So this is the JK flip-flop with asynchronous input. We have additional input over here. We have preset bar and clear bar. This is JK flip-flop with the positive going transition with preset bar and clear bar. So this is example for timing diagram of PGT JK flip-flop. Okay, so for example, we want to sketch the Q for this JK flip-flop with asynchronous input. So the first thing, you need to draw the vertical line for preset and clear when it is active. So for this one, this is when the preset bar is active, and this one when clear bar is active. When the preset bar is active, Q will immediately become 1 over here, and clear bar, when it is active, the output will immediately become 0. We will discard the transition of clock when preset and clear is active. So the next step is we draw the vertical line for all the triggering age of clock except for the part when asynchronous input is active. Alright, so this one is negative going transition of flip-flop. So we draw the vertical line for clock. And then next, so we already have the output here and output here. So first thing, the Q is initially 0. So the first clock is here. So this one 1 0. The first clock when JK is 1 0 is supposed to be 1. Like this, right? And the next clock, this one just okay, right? So when see here, this is 0, it become 1 after the first clock. It will continue with the preset output. And this one, there's no clock here, so we hold until the next clock. So this clock 1 0, it is 1 also. And then the next clock is 1 0, still 1. But this one we have Q equal to 0 because of the clear bar active. And this moment there's no clock triggers, we just hold until the next clock. So this one 0 1 0 1, it will become clear, and then the next clock is 1 0, will become 1. So you can get like this. This is the final Q for asynchronous JK flip-flop. And this is another example of timing diagram of PGT. So you first need to draw the vertical line here when the clear and preset bar is active. So you can see this one we get preset Q equal to preset, and this one from the preset, and this one also clear from the clear bar. So then after that you draw the vertical line in the clock edge, and we evaluate Q every time the clock edge. So this one like 0 0, so that's why we get a hole over here. The second clock here is 1 1, so we get toggle from the previous output. The next is also 1 1, is toggle. Next is 0 0, is will hold. And then this one 1 0 will be set. This one 1 1 toggle, and this one 0 0 is whole. Just a little moment before it go to the preset queue, and then preset will go through the clock edge, so it hold because of this one. Alright, this moment. So right, can see here there's some moment between preset and clear active. So we have hold over here, and then continue with the clear, and then toggle. So this is the available IC for JK flip-flop with the preset and clear bar. And the last flip-flop of edge trigger is D flip-flop. It's same function as or working operation as D latch, except we have clock input. Means that it is triggered when there's an edge of clock pulses. So in this kind of this one is PGT. Alright, this is the truth table for D flip-flop. When 0, it becomes 0. 1, it becomes 1. So for example like this, we have two type of D, 2D, D1 and D2. So we have Q1 and Q2. So Q1 based on the D1, Q2 from D2. So it is positive going transition of D flip-flop. So you can see here when it is 0, it also 0 here. This one 0, also 0. But this one, the second clock, this is 1. This one become 1 over here. Alright, this one also 1. So here 0 0, also 0 0. Alright, so it is based on the D input. So that's all for